Can you guys type into the chat privately what word is in the word parallelogram so that you remember this as the definition? What's in the word parallelogram? Okay, and maybe I'll say it this way because that way you'll remember it. That's funny, Cody. So you'll remember this as not like if you search definitions of parallelograms on the web, it might include other properties that we're going to discuss. So I just want to clarify for our purposes, parallelograms only talk about opposite sides being parallel. It doesn't talk about any of the like other things like opposite sides being congruent, which is later something that we prove on the next step. So just parallelograms, opposite sides are parallel. Okay, so it's a quadrilateral, which is a four-sided figure. It's funny because I was asking my daughter this morning, have you seen my notes for parallelograms? And she's like, oh, I know what a parallelogram is. So I know you guys have seen this before, but we're just studying it a little bit in more depth in terms of the properties. So a quadrilateral with two pairs of opposite sides parallel. Okay, so it has, remember the word congruent is not in parallelogram. So only the word parallelogram, parallel is in the word parallelogram. So a quadrilateral with two pairs of opposite sides parallel. Below that, and I'll start to highlight, are properties that we're going to first prove are true. And then after we prove are true, we can just use it as a statement. So for example, like when we were proving certain theorems were true, after that, like vertical angles are congruent, that's something that we proved. Eventually, we're just able to use it. So same thing here, the same idea. We're going to prove it, and it's a perfect segue from why the congruent triangles were grouped into this unit as well. They're related in that sense. We need congruent triangles to prove this property. So you guys are given parallelogram EFGH. So let's go ahead and write that as our given statement. So number one, this is the symbol for parallelogram. And if you do that symbol in front of four letters, that names a parallelogram, and you would just list the letters that are part of that parallelogram in no particular order, then I would know that you're referencing a parallelogram. So that is given. Okay, statement two usually falls in line with if you're given that if you're given that the shape is a parallelogram, what is it that you can conclude by definition? Okay, so by definition of parallelogram, because that's the only possible thing you guys can do at this point from that given statement. By definition of parallelogram, you know that the opposite sides are parallel to each other. So for example, you know HE is parallel to GF. You also know HG is parallel to, wait, I think I said that, but I wrote something else. So just go ahead and list out, and I'll say it again. HE is parallel to GF, and also HG is parallel to EF. They sound kind of the same because the letters rhyme too. Okay, so again, by definition, I can conclude that. What's missing from this diagram is the fact that a parallelogram is comprised of two triangles. So what I'm going to do is draw what we call an auxiliary line, which is basically an imaginary line through EG. I'll do that for this proof. I'll state this, this drawing of this auxiliary line, but you won't have to do that for any of the proofs that you guys do. Generally, what you guys need is already labeled and provided for you, but because we're proving a property, we'll go ahead and state that as a step. We drew, so draw EG. We know that we're allowed to do this because E is a point and G is a point. Through any 2 points, you have exactly one line. So that was from the first unit. Through any 2 points, there is exactly one line. And I think the two people who needed the definition, are you good with the definition now? I think a couple of you guys asked me to scroll back up to the definition. Okay, thank you, Richard. Okay, so step 4. Now, just to show you guys what we're trying to prove, we have two triangles here. we're going to want to prove these two triangles are congruent so that we can prove EF is congruent to HG, opposite sides are congruent, and that HE is congruent to GF. Okay, so the next thing that I'm going to have you guys do is label some of the angles so it's just faster for us to reference. Can you guys label that 1, 2, and 3, 4? And in the chat box, can you private chat me, what do you guys know if those, by definition, if those opposite sides are parallel, what do you guys know about angle 1 and angle 2, and angle 3 and angle 4, and the reason why that's true? What do you know about 1 and 2 and 3 and 4? Okay, perfect. You guys stated 1 is congruent to 2 and 3 is congruent to 4. And many of you guys are saying that it's by AIA that we know. And that's true because those opposite sides are parallel. Therefore, the alternate interior angles of those sides are also congruent to each other. So 1 is congruent to 2, 3 is congruent to 4. Now, if I wanted to prove that those two triangles are congruent, what do you guys think might be the next move that we move to? Good job, Cody. Anyone else? What's the next step that we want to state? Okay, so since those two triangles have a shared wall, the shared wall being EG, we might want to say EG is congruent to itself by reflexive property. Good. Okay, take a look at what you guys have now. You have EG is congruent to itself. You have 2 is congruent to 1, 3 is congruent to 4. Why are those two triangles congruent to each other? Why is triangle GHE congruent to triangle EFG? Okay, very good. You see that it's why two triangles are congruent, remember, are the 3-letter acronyms or HL. So ASA, side, 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 angle, side, and then HL. So in this case, we have an angle, 2 sets of angles, and then a side that's included in between. So very nice. So angle, side, angle. And finally, in all of the proofs that we've done, we've proven that the triangles are congruent so that we can state certain parts are congruent. So EF is congruent to HG, and FG is congruent to EH because of what reason? Go ahead and type it into the chat. What reason do you know follows typically two triangles are congruent? Good. Those are corresponding parts of congruent triangles. Very nice for remembering all of that. I know it's been a week, 9 days exactly since you guys took that last test, which, by the way, was a huge success in the sense that I think the class averages were in the upper 80s. Some teams in certain periods averaged an A on that test. So nice job on that. And then can you guys type into the chat what you guys think about remembering? Was this difficult for you guys to remember the triangle part of it as you were doing this proof? Was it hard for you guys to remember that? Being 9 days since you guys last saw it? Okay, good. And some people are like, oh, it's coming back to me pretty easily. And then others of you guys are saying it's taking a little bit, but it'll come back to you guys, especially triangle congruence. Okay, so down below here, you guys have another property, which I'll highlight. So for this one, it's saying that you guys, if you know that it's a quadrilateral, not only can you guys assume that the opposite sides are congruent, but you can also assume that opposite angles are congruent as well. Okay, so we're gonna do the same exact thing, kind of like rinse and repeat. The only problem here is that if you look at the first diagram that we drew, it was HG and EF, the opposite sides, were parts of those two triangles. HE and GF were also parts of those two triangles. So all I had to do was draw one diagonal, divide that parallelogram into two triangles, and then those opposite sides happen to be parts of those triangles. Okay, the problem with this one is that when I'm trying to prove opposite angles are congruent, using a very similar process, if I drew the diagonal through EG, the opposite angles of the triangles that result are H and G. But that diagonal then kind of cuts at a funny angle, E and G. So that's not going to work for proving E and G are congruent. So what we have to do is simultaneously set up another set of triangles. And this time we're going to divide the two sets of triangle at the diagonal HF. And then that way we can then say E and G, once we prove that the triangles are congruent, we can prove E and G are congruent. So to visualize that a little bit more in an efficient manner, can I have you guys redraw that parallelogram and label it the same way? So just redraw that parallelogram twice. Label the letters the same order. Okay, so through the first parallelogram on top, the top parallelogram, I'm going to draw the line HF, okay, the diagonal HF. For the bottom one, this time, and so the top parallelogram, by the way, when I divide HF, or divide the parallelogram into two triangles, that's going to allow me eventually to prove G and E are congruent. Now I'm going to set the diagonals going in the other direction. Oh, sorry, I just redrew the same thing. Okay, no, now I'm going to make sure it goes through EG, and then that way I can prove H and F are congruent. Okay, and it's nice because we can do this all just within one proof without having to divide it into two different proofs. So it's essentially the same steps. Okay, so start off with what we know. EF GH is a parallelogram, and that is given to us. Step 2 is, what do I know if I know it's a parallelogram? I know that opposite sides are parallel by definition, but I'm going to say that once you guys prove things like we just proved in the above proof, that opposite sides of a parallelogram are congruent, now we can just use that, okay, because we've already proven it's true. Going forward, we won't have to recreate this whole proof. We can just say EF is congruent to HG. So we can state the reason being what we know above. So EF is congruent to HG, opposite sides. And the other set of opposite sides is HE is congruent to GF. And the reason being opposite, and the statement that I'm writing is really a summary of the above property. Opposite sides of a parallelogram are congruent. Okay, let's go ahead and label that in both sets of triangles, and then I think it's going to become more clear for you guys. So if you know that HG is congruent to EF, go ahead and mark it in both sets of triangles. HE is congruent to GF. What would be the next logical step for you guys to say? If we're trying to prove that both sets of triangles are congruent, very good. You have the shared side, right? We have that shared side being EG, and then the other shared side being HF. So in both sets of triangles, you guys have a shared side. So EG is congruent to itself in the bottom parallelogram, and then you also have HF is congruent to itself. And that is by reflexive. Okay, once you guys state that, what's true about those two? Why are those two triangles now congruent to each other? Or actually, both sets of triangles. Okay, good. And then I'm going to give you guys a moment to write down the triangle congruent statements, being triangle HEF is congruent to FGH, and triangle EHG is congruent to triangle GFE. So I'm listing both sets of triangles because they're congruent for the same exact reasons. Okay, so good. You guys wrote side, side, side. We have three sets of sides being congruent to each other. And then lastly, if you guys know that both sets of triangles are congruent, now we know that also angle H is congruent to angle F, and angle E is congruent to angle G. What's the reason for that? Thank you, Benjamin. Good, Vivian, Christian. They are corresponding parts of congruent triangles. Very nice. Okay, so that's it. And then after this, we can say, if you know that a quadrilateral is a parallelogram, you can conclude that opposite angles are congruent. We're not going to prove the next two properties, but we will just talk about why we know that it's true. Okay, so you, in theory, could prove it's true in a similar way by setting up triangles. Okay, the next two properties I'm going to have you guys highlight is if you know a quadrilateral is a parallelogram, then consecutive angles, which I'm going to have you guys write below here, is another way of calling same side interior angles are supplementary. Okay, so when you guys look at the picture of the parallelogram and you picture the bottom and the top lines being parallel to each other, okay, this angle here and this angle here, those angles happen to be same side interior angles. Okay, how many sets of same side interior angles do you guys have in a parallelogram, you think? How many sets of same side interior angles do you have? So we know angle H and angle E must be supplementary to each other. Good. Some of you guys are typing out 4. So G and F also happen to be across this transversal, and they are same side interior angles to each other. And then if we erase all of that and look at the other set of opposite sides being parallel lines as well, then you guys can see that this is a transversal, and then you have another set of same side interior angles going in that direction. So we have that the next set would be angle H and angle G. And remember, supplementary means that they add up to 180 degrees. My H looks funny here, so let me fix that. Okay, H and G, and then E and F. Okay, so now looking below that, so that's going to be, so far 3 properties, right? We know opposite sides are congruent, opposite angles are congruent, and consecutive angles or same side interior angles are supplementary to each other. Our last one that we're going to look at today, again, if you can highlight this, is diagonals of a parallelogram bisect each other. So above bisect, just write a reminder that that means that it cuts each other in half. Okay, so when they say bisects each other, that means you guys can view, for example, TR as the knife that divides QS into 2 congruent segments, as well as the other way around, as QS being the knife that divides TR into 2 congruent segments. So let's go ahead and mark off what we would, if you're looking at a parallelogram, you're looking at the diagonals, the next assumption you can make is that QM is congruent to MS, and that's an interpretation of the diagonals bisect each other. What's the other congruent statement you guys can make? Go ahead and type it into the chat. You would know that QM is congruent to MS. What else is equal to what else? Okay, very good. TM is congruent to MR. The other set of segments are on the diagonal are also congruent to each other. TM is congruent to MR. Very nice. Okay, so those are all those 4 properties, and the definition of the parallelogram are the things that you guys are going to take and apply at this point. So whatever problems we don't finish, it's a light homework assignment you guys will complete on your own. Okay, so question 1, I think we did all of question 1 through 4 and number 7. And let me just double check the time here. Okay, so we'll see what we can finish. Okay, so if you guys know PS is equal to 5, what's QR equal to? Go ahead and type it into the chat. Okay, so PS being the opposite side to QR, we would then know it must be equal to 5. Very good. Okay. And then for 2, if you know that PR is equal to 20, what must PX be equal to? So very good. Remember, diagonals bisect each other, right? So look at the figure. If you guys said 20, look at the figure again. PX should be half of that, right? So it should be good. It should be equal to 10. So if the whole thing is 20, the whole diagonal is 20, then PX is half of that. Okay, so then the next picture, the next part is that you're given that angle QPS is equal to, so let me draw that out. QPS is equal to 125 degrees. What's QRS equal to? What's QRS equal to? So being the opposite angle, that's 125 degrees. Very good. And then now they're referring to PQR. Okay, PQR, I'm going to highlight right here. PQR, they're saying is equal to PSR, which, yes, that's true. They're opposite angles. But knowing that QPS is 125 degrees, what's the measure of each one of those highlighted angles, PQR and PSR? Okay, good. Are they 125 degrees? So some people put 125 degrees. Make sure you look at the diagram again. Okay, so if you guys look at the pink angle and the yellow angle, they are same side interior angles, right? So this angle right here, the yellow angle right here, is same side interior to 125 degrees. So if they're same side interior angles, they should be supplementary to each other. So 180 minus 125, so I'll write that out. 180 minus 125 should give you guys the 55 degrees. That is the measure of each one of those angles. Okay, any questions so far? Had some of you guys typed in some other answers, just making sure you guys are getting those answers corrected. Okay, now for your next one, the next one is asking if you knew that angle 1 is equal to 27, angle 2 is equal to 30, what is angle 3 equal to? Let's start with that. What's angle 3 equal to? What do you guys think angle 3 is equal to? Good, those of you guys who typed it out. Oh, okay, that's what you meant by angle 1. I think you guys mean angle 1. So if angle 1 is equal to 27, then therefore angle 3 must be equal to 27 as well. Very good. And that is for the reason of their alternate interior angles. And we know with parallelograms that the opposite sides are parallel. So what would the angle measure of PSR be equal to? If you guys knew that that's a parallelogram, what's PSR equal to? And be careful with that, you guys. PSR is the entire angle. Okay, good. Well, just be careful as you guys add it. If you add 27 and 30, you get 57 degrees, right? It's opposite angles to both 1 and 2. So we add the 2 to get 57 degrees. Good. All right, our last problem for today is number 7, which I'm going to zoom in on. Okay, so I'd like you guys, first, there were several questions on the test about like, is that letter is the variable referring to the side or the angle? How do you guys know X and Y are referring to angles when you're looking at that diagram? Okay, yes. So I know some of the edge elastic diagrams, it was hard to read whether or not that was a degree symbol or not, but that they are degree symbols, they're inside, they're closest to the angles, good. So all of that, but mainly because of the degree symbol. Okay, the next thing I want you to do is in the chat, can you guys tell me what you think A is equal to? What do you guys think A is equal to? You guys, is A referring to an angle or is it referring to a segment? It's a segment. Okay, so if you notice A is this segment right here. Okay, there's no degree symbol. So A is supposed to be equal. If the diagonals bisect each other, then it should be equal to 10. Very good. Can you guys tell me what B is equal to? Oh, that's what I figured, Cody. Okay, very good. If B happens to be the opposite side of 10, then it would have to be equal to 10, oh, not 10 degrees, but just 10. Okay, now we're gonna work on the angle measures. Okay, so the angle, this one's a little bit tougher to do. That's why I picked this one to do with you guys. Can you tell me, I'm gonna highlight an angle and draw an arrow to it. Can you guys tell me what the degree of that highlighted angle is equal to? What's the degree of that highlighted angle equal to? Okay, very nice. You guys said same side interior angles to this angle down here, right? So the same side interior angles to this, so it must be 62 degrees. Okay, so the triangle that I'm going to now focus on, this triangle in orange, what type of triangle is that? From what you guys learned before, Christian, that is correct. What type of triangle is that one? The orange triangle. Oh, classify by sides. Good. So you guys notice that the diagonal is 10, the side is 10. So this must be an isosceles triangle. Therefore, yes. Therefore, you guys know that the base angles across from those opposite sides must be equal to each other. So x must be equal to y. If you haven't figured it out already, because some of you guys have, can you figure out what x and y are equal to? What is x and y equal to? Knowing that the top angle, that vertex angle, is 62 degrees. Good, Benjamin? Okay, so just to work the problem out with you guys, if you took 180, 3 angles add up to 180 degrees, you subtracted out the top angle of 62, you guys would have gotten 118 degrees. Okay, so if the 2 bottom angles have to add up to 118 degrees and they're equal to each other, then we can divide that in half and get that the correct answer for x and for y is that it's 59 degrees.